Welcome to this video. We're going to learn about magnetism. We'll start by comparing it to electricity. And what do we know about electricity? Well, there are two different types of charge: positive charges and negative charges. What carries positive charge? Protons. What carries negative charge? Electrons. The proton has the same charge as an electron. It's just that one is positive, one is negatively charged. In magnetism, there are similarly two different types of magnetic poles. There's the North Pole and the South Pole. Now, unlike charge, there are no carriers of North Poles and no carriers of South Poles. This is a strange idea, but you cannot have a single isolated North Pole by itself disconnected from a South Pole. If you find one, then you always find the other. Magnets exert forces on each other without touching. They can act at a distance. Now, what other things do you know of that exert a force without touching? Take a moment and think about this question. The other things that can exert forces without touching are gravity, all masses, gravity, which pulls on all mass, and electricity, or we'll say the electric force, which pulls on charge. So how do you think magnets pull on each other at a distance without touching? What do you think? Well, how does gravity pull on things without touching? How do electric forces pull without touching? The answer is through a field. We call it the magnetic field. We use the variable B for magnetic fields, and the unit of field strength for magnetic fields is the Tesla. T-E-S-L-A. We abbreviate it capital T. When you write out the name Tesla, the word Tesla, as a unit, it's actually lowercase t, but the abbreviation is capital. Now, magnetism is different from electricity and from gravity. We already saw one difference, right? In electricity and electrostatics, you have individual positive charges, individual negative charges. In gravity, you have individual masses. But in magnetism, there is no such thing as an individual North Pole separate from a South Pole. And here comes a second difference. When we talk about the strength of the field, how strong is the field? For the case of gravity and electricity, we define that strength in terms of the force acting on a small test particle. So the test particle could be a small positive test charge, or it could be a small test mass. Right? See, in the equation, we define the strength using force and a test mass or a positive test charge. That's not the case for magnetism. Okay? We do not do it that way with magnetism. Not true. For the magnetic field strength. Now, we know that the G field strength, the gravitational field strength, points where a small test mass would get pulled, and the electric field strength points where a small positive test charge would be pulled. Right, this is our test particle. But where does the B field, the magnetic field, where do those field lines point? Before we answer that question, let's look at an example. Right? We're going to make an analogy. The magnetic field lines, when you have a bar magnet like this with a north pole here and a south pole there, the magnetic field lines bend exactly as you have when you put a positive charge near a negative charge. So this bending shape is the exact same as this over here. Okay. When two magnets interact, each magnet has a north and a south. The rule is the north of one magnet is attracted to the south of the other, just as positive charge is attracted to negative charge. So what's this have to do with field lines? Well, imagine you take a small compass, right? And you put the compass right here in the field. North would point towards south. The north pole of the compass would point toward the south pole of the magnet, because north is attracted to south. So let's write down north is attracted to south. North and south attract, just like positive and negative. So what's the rule for field lines? The field lines, the magnetic field lines, right, the B field lines, point where the north pole of a small compass would point. That's the answer. And I'm going to change this to N pole, where the north pole. So take a moment and number 3 and number 4, take a moment to answer those two questions.